I am grateful for Ece Mutlu for accepting this seminar. Let me very briefly introduce Ece to you. Ece Mutlu is a PhD student in Industrial Engineering and Management Systems program and graduate research assistant in the Complex Adaptive Systems Laboratory at the University of Central Florida. She earned her bachelor's degree in both chemical engineering and chemistry, so she's a double major at Boğaziçi University in 2015. Ece received her Master of Science degree in chemical engineering at Boğaziçi University in 2017. So she was she graduated from our graduate department, and her thesis studies cover robust statistical analysis for control charts using many processes as a quality control measure. Actually, we worked together with Ece during her master's degree. Then she went to America, United States. She aims to pursue her academic career in network science and social contagion analysis. I think this is how it's pronounced. And her research interests are computations, social modeling, and statistical analysis of complex networks. So it's a pretty interesting and non-chemical engineering topic. But as you know, chemical engineers are people who work in fields other than chemical engineering. Right, so the floor is yours, Ece. Yes, please, you may start.
Thank you for inviting me, and thank you for the great introduction. Actually, I put all of this information on my main slide too, but you summarized everything, so I don't need to go through. But you can see that I have worked very interdisciplinary, more multidisciplinary maybe, and I have changed my studies from chemical engineering to chemistry, then industrial engineering. Now, I hope it will be the last stop for me. I will graduate in a year and then continue in industrial engineering. I first came to UCF, the Complex Adaptive Systems Laboratory. This laboratory was mainly working on 6 main areas. And these were social complexity, big data, deep learning, lifelong learning, innovation and economic prosperity, and cybersecurity. The common thing about all of these areas they are all related to complexity. And when we are saying complexity, we can define these complex systems as an area concerning the description, prediction, and explanation of systems that exhibit patterns of changing behavior at the macroscopic level, emerging from the collective actions of many interacting components. I wanted to put these 3 examples because I think they are really explaining well what the complex system is. When you look at brain, for example, this is one of the most complex organs in living organisms. And you know that all of the parts have they are responsible for different things, and they are doing their own actions with their self-organization, but also they have some interaction between them, and this interaction is creating an emergent situation, and then we are coming up with the action that we are doing. And this structure, all the self-organization and the inter-organization and all the emergence is creating a very nonlinear structure. That is the reason classical methods or many machine learning algorithms or other predictive algorithms are not performing well. And we can say that their predictability is very limited, and they have their own methods for this purpose. And I hope I will explain it in the later slides. I also wanted to put these and human interaction related examples, because this is also same when you look at their own components. They have their own units, but then they are creating a whole structure when you look at from a bigger perspective. But I am interested in mostly is the human interaction. Human interaction is also creating a complex structure, because human itself is a complex structure. So when they are interacting with each other with all the uncertainties and all the nonlinear relationships, they are creating very complex structures that are hard to deal with.
I cannot see your picture with the presentation. I don't know about other people, but is it because of your settings?
Maybe. Do I need to pin? Let me.
Ben görebiliyorum.
Can you see both presentation and Ece's picture at the same time?
Yes. Yes.
Okay, so
Yes.
it's my problem. Okay, so Ece, yes, you may continue.
Okay.
So,
Now
all right.
I think my video probably it will work.
No,
better.
it's probably my problem. So, okay, that's okay.
Okay. And I wanted to put a Aristotle quote here: the whole is more than the sum of its parts. This is what complex system is exactly. You cannot understand all the individual dynamic. You cannot understand the whole, the bigger perspective by looking only the parts of it, but you need to understand their interactions or their composition together. I wanted to first explain, because my research area is a little bit different than chemical engineering right now. I wanted to explain how transition was for me. It wasn't easy. And first, when I came to the lab, I don't know, it might be different for different advisors or countries or maybe departments. But for me, it was like, you have 6 areas we are focusing on, and you need to come up with your research idea, and you need to figure out what you want. But that wasn't an easy choice when you are not very familiar with the area, because I had a chemical engineering background. I was very unfamiliar with the industrial engineering studies. So it was not an easy task to start finding a research topic, which is really promising and novel. So I literally made a research, how can I find my research topic? That was really beginning of my PhD. And there was a really good article on Stanford's website. And I think that although it is very intuitive when you look at, you can say that, okay, this is very easy to predict. But for me, it was really like a checklist, and I wanted to satisfy all of these criteria when I look at. First, I think the research topic should hold your interest for a long time, because this is really a big commitment, and this is really, you are really dedicating too much time, even if it is master or PhD, or maybe after your PhD career. I think it is, if it is not interesting for you, it might be really tough in the end. So it's better to find your interest to study beforehand. And it must be manageable in size, because you have a limited time, and you might have really interesting questions, but to answer these questions should be manageable in the end, and you should be sure that it is not already been sufficiently researched, but you are making an original and significant contribution. Other criteria was it must be doable within your time frame and budget, and that was also important for my case. In the upcoming slides, I will show you some examples about Twitter data. Although people are sharing their posts very easily and everything seems like accessible, it is very hard to get it. It is expensive. It is very hard to collect data. Sometimes you're collecting wrong data and collecting again. So all these actions requiring some time and budget. So you should be aware of all these data. How will you deal with all of your data in terms of time and budget? And maybe the most important thing is that it should be acceptable to your committee members, because these people are more experienced than you. And at the end, they will decide, could you find really a novel topic, or is it really a promising for in the future? So it's important to get ideas from these people. When I look at these criteria, I thought that the social contagion analysis was one of the most interesting areas for me. And specifically, I wanted to focus on online social networks. When I say contagion, I think it can be very intuitive, but the first thing in my mind was how contagion is defined in epidemiology, because we know that contagion is spreading of disease from one person to another, and this is how whole epidemiology is based on this assumption. But after that, people realize that ideas, emotions, and behaviors can be also contagious too. People can get infected with their ideas, emotions, and behaviors. So researchers are divided contagion into 2 categories, which are biological and social contagion. You are familiar with the biological contagion, because in this one, even one single active node is enough for spreading. It's like ongoing COVID pandemic, because there was only probably one infected person at the beginning, but then it ended up with being a pandemic. But social contagion is a little bit different than this. Although this spread used to be regarded as a pathogen in a biological spreading, empirical studies show that social contagion is more complex than biological contagion due to social, cognitive, and behavioral differences of humans. So it requires a different, although it has the same analogy with the epidemiology, it requires more complex calculations. The motivation motivation for me to work on online social networks, firstly was how big the data is actually, because people can share their ideas freely. They have an ability to reach multiple people simultaneously. And it is very easy to find communities and how people are getting connected to each other. So this is the reason social media related studies are used, or social media data is used in very different areas, from community detection to consensus formation, link prediction, polarization, or influence maximization. As you see, all these examples are very different examples. This is the reason it is considered as an interdisciplinary area, because there are, some of them are related with sociology, some of them are related with marketing, like influence maximization, for example, or some of them are the link prediction related ones are actually a recommendation systems that we are dealing with, and it is more computer science related area. So this is very interdisciplinary area, and you can really work on very different topics in that area. But the main motivation when I look at social media, which is social media, and what should I study on social media, was that I think the most interesting application was the studies wherein the dynamics of information formation, diffusion, and manipulation are analyzed. Because when we look at if social media is beneficial or not, it is very controversial topic. But when we look at this question, actually, it is really good to get a fast update on current events. If there's any emergency, for example, in case of, for example, natural disasters, in such case, you can access so many information, and you can hear from people from different countries, and that's really beneficial in these kind of situations. But at the same time, there are some malicious users that may try to manipulate or disorientate the true information. And that causes very quite harmful situations. And at the end, people might be misinformed, and that might be really chaotic. So having a control on this diffusion mechanism, the information diffusion or information contagion mechanism, is very important when we look at all these factors. You can see how I like this area, and I have different kind of studies. These are my publication I have made. And today I wanted to give you two examples of them. The one is quantum contagion, and the other one is bots and humans difference in moral rhetoric. The first one I will explain is more like a theoretical study, but the second one is Twitter application. So I wanted to give some different examples to show you how these other studies, chemical engineering, can be done. The first one is the quantum contagion paper that I said, and this is the more the paper that I was having more theoretical approach. And again, we are starting with the social contagion theory. This social contagion theory is very old, actually. It is proposed by Libon in 1895. And it says the impacts of social influence on people's perceptions, attitudes, and behaviors in a concept of diffusion, and tries to understand the causal factors behind their adoption. By saying adoption, I mean they are, when you have an idea, you are trying to spread and you are trying to convince people. And when you can convince successfully, it means that that person is adopted to your behavior or your information. This is how this adoption terminology is used in social contagion. The modeling the complexity of individuals is mainly stemming from the heterogeneity of individuals, and that is highly addressed in the literature. People are trying to put some complex threshold distribution or adoption threshold distributions to model the complexity of individuals and heterogeneity of their adoption profiles. But there was something missing in the social contagion analysis, which is the uncertainty in their decision-making processes. Because even if we have really a perfect modeling about their threshold behavior, people are uncertain and their decision might change due to the interaction, because their emotions, subconscious feelings, and subjective biases might affect the decision-making processes. So there is an assumption in classical social contagion theory, which is individuals are perfectly rational and do follow the rules of classical probability theory and logic while taking an action during the process. But it is known that it's not true, and there are a bunch of papers and studies showing that people are not perfectly rational, and they may have quite different behaviors under uncertainty especially. So this is more like a cognitive science literature actually, but the examples in literature, in their literature was quite interesting, and I wanted to put some examples on them and how we inspired by these approaches to define the uncertainty in social contagion analysis. There's something called shooting principle proposed by Savage in 1954. And it says, if one prefers action A over B under state of the word X, and again prefers A over B under state of the complementary state of word X, then this person prefers action A over B when she doesn't know the state of the word. This is actually one of the foundational hypotheses in classical probability theory that we are using. When you look at this example, in this example, Tversky and Kahneman conducted an experiment, and in that experiment, they showed how people can violate the shooting principle. This is called a disjunction effect, and it is a very intuitive and very simple experiment, but you can understand what I mean better, I guess, after this experiment. Participants are asked to play 2 consecutive games, and they're informed that they may either earn $200 or lose $100. And in both of the games, this is the case. You may either earn $200 or lose $100. But they are asked, what will you do in the second game if you won the first game, if you lost the first game, and if you don't know the outcome of the first game. When we look at the classical probability theory, we can calculate the probability of player playing the second game with this conditional probability formulation, as you see here. I cannot point out, but you see on the left bottom corner. The results were a little bit interesting because it was showing that shooting principle is not valid when humans are involved in the experiment. Because first, the state of the word X was accepted as winning the first game. People are selected to, majority of the people, 69% of the people wanted to play the second game if they know that they won the first game. Again, if they lost the first game, 58%, the majority again, wanted to play the second game. So if we define the state of the word X as the winning the first game and then complementary, the opposite state as the losing the first game, when they don't know the outcome of the first game, what we are expecting is that majority of the people should select playing the second game, but that wasn't the case. And because of the uncertainty, majority of the people didn't want to play the second game. In another example, which is called the conjunction fallacy, again, conducted by the same people, Tversky and Kahneman, in 1979. Participants are informed about the student, Linda. Linda used to be a philosophy student at a liberal university and who used to be active in anti-nuclear movement. This was the only information, only statement they are given. And then they are asked, what do you think about Linda now? She might be A, active in the feminist movement, B, a bank teller, C, active in the feminist movement and a bank teller, or a bank teller and not a bank teller. When you look at all these examples, you know how joint probabilities and marginal probabilities are working, but people, due to their biases in the statement, people selected option C more than option B. So although the statement indice, including a joint probability, and it should be lower than option B. It wasn't the case when people are involved. So this example, and there are more examples, but I just wanted to keep it short, shows that people do not follow the rules of probability theory and logic while making decisions under this. So the main problem here is the uncertainty, and the uncertainty is generally dealt with the quantum probability. So quantum probability plays an important role in explaining several inconsistencies in decision making in so many studies. So we wanted to use quantum probability approach to simulate human decision making in social contagion mechanisms. If we want to look at more closely to how decision making is done by human with a classical method and the quantum models, you can roughly see like this. In the classical method, what we are saying is that human interference deterministically jumps between definite states and then stays in a single definite state across time, and you will come up with the final decision in the end. In quantum model, on the other hand, there are indefinite states and superposition at each time point, and this superposition shows that you might be conflicted, confused, ambiguous, or uncertain. So all beliefs are occurring at the same time, and you are coming up with the final decision with the interference effect that is not easy to model, and that's not easy to observe either. So the research question, the first research question was to better model the complexity of human decision-making and explain existing paradoxes and fallacies. Researchers developed numerous quantum-like approaches. So these are examples working well in different areas, but does the quantum-like approach model the dynamics of social contagion better? To understand the differences between classical and quantum social contagion, I wanted to put a brief introduction to quantum probability, but I will not worry you too much. It is just simple introduction. You know, the classical approach, it follows a theoretic representation, and sample space is defined as a set of possible events. And this is how it looks like on the left side, but quantum approach follows a vector space representation, and sample space is spanned by orthogonal basis vectors in Hilbert space. So in classical approach, we know some operations defined as intersection, union, distribution, because it obeys the set theory. But in quantum approach, events are defined through a superposition state, which compresses the occurrence of all events. And when you apply quantum probability approach, you are also bringing some wave function amplitude, which are denoted here with the exponential values. So it becomes more complex than the classical approach. This is how the differences are mainly coming from in my study, because when you have mutually exclusive events and when you try to find their union here, as you see on the first line, normally you can identify them with their the summation of their individual probabilities. But when we apply quantum approach for this, first we are converting all of these probability values to quantum amplitude by applying Born's rule, and then inverse Born's rule give us this final equation, which includes interference terms. These interference terms means that because we don't know the exact angle or exact direction of these Hilbert space representations, we don't know angle between vectors too. So these interference terms are actually defining the angle between these different vectors. While applying quantum social contagion, we wanted to use a well-known model to make it less complex, which is SIR model. And it is commonly used method in behavior spreading model. And this one, it is again working like epidemiology. There are a lot of similarities between these two departments. Just the computationally, they are changing actually. Each individuals fall into one of three states: susceptible, adopted, and recovered states. Susceptible individuals are individuals do not adopt the behavior, and adopted individuals are already adopted the behavior and tries to transmit the behavioral information to neighbors. And recovered people either lose their interest or they will not transmit the behavioral information in the future. So when we assign probability values from for the transition from susceptible to adopted or adopted to recovered state, we can start using edge-based compartmental model to quantify this the social contagion, all the spreading mechanism. In this one, again, I will not go into more detail, but I can just roughly say that there's a network, people are connected to each other, but we don't know which people are connected to which people. So we are making an assumption that there are two individuals called agent U and agent V, and we are first looking for the probability of these individuals being susceptible and adopted, because this adopted person will try to transmit the information to susceptible person. And after defining these two probability values, we are looking how likely they might be connected in the network structure. Then when we calculate all of these probability values, we can come up with the fraction of susceptible individuals by time t, and then we can use ordinary differential equations to define the final adoption size. These were the results that we have. First, we tried to give different scenarios. The TB values denote the different thresholds. As we said, humans are heterogeneous, and while we are including uncertainty in their decision making, we want to also put a simple heterogeneity in their threshold values. So TB is equal to 2 means that minority of the people have twice higher threshold value than the majority of people. And in the other one, if the majority of people have threshold value that equals to 1, minority of people are hard to convince and their threshold value is equal to 4. It's like 4 times higher than the lower people. So when we look at the results here, these we separated, there are 2 different uncertainty here becoming from the transition from susceptible state to adopted state, and from adopted state to recovered state. So we divided these 2 into SA interference and AR interference terms. When we look at the classical approach, we can see that final adoption size increases discontinuously with increasing transmission probability. You can see that there is on figure C, you can see that there is a critical value, which is equal to 0.262, and that means that until some point, the adoption behavior shows that continuous behavior, then it breaks down and it follows another continuous behavior. But this discontinuity is not observed when there is an SA interference. So when we put the uncertainty term inside the formulation, we can see that final adoption size increases continuously with increasing transmission probability. When we include only the AR interference term, we realize that this continuous change is observed again, but we observe break-even point at lower critical points. All these are the theoretical results, but when we try to explain them, when we try to make the inference, what do they mean? We can say that final adoption size increases continuously mean that we can predict the structure easier than we can predict structure in quantum contagion easier than classical contagion. And also decreasing critical points mean that global adoption is easier to achieve. When I say global adoption, it means that so many people, almost all people adopted the information, and local adoption means that it is observed when the transmission probability is lower than this critical value. Only small fraction of individuals adopted the behavior. These are the results of final adoption size with respect to initial probability of being a higher threshold value and the transmission probability. These results are showing the results for numerical simulations and the theoretical analysis by using classical approach. You can see that this continuity is not well defined, so there are a bunch of differences in their comparison. So when we compare our result with the classical and quantum social contagion result, we saw that modeling social contagion with quantum-like approach performs better compared to the classical method, since it can better predict the final adoption size at close to critical transmission probabilities. That was the theoretical study I wanted to show, and we have published this paper 1 year ago, so there's still quite things to do. The first idea as a future direction was the investigating the coevolutionary dynamics when spreading mechanisms are more than, when we are looking for the spreading mechanisms of more than 2 contagions. These contagion, you can imagine like there are 2 supportive information just spanning around the network, and they are supporting each other, or maybe they are competitive to each other. Probably they are creating more discontinuous and more nonlinear structures, and that might create very different results. So this will be the future direction we will follow on this study. If you have any question, I can stop here for a second, or if you want me to continue, I can continue with the other study.
Ben bir şey sorabilir miyim? Can I ask something?
Yeah, sure.
You mentioned 3 states of people, adaptive, recurrent, and susceptible. How do you determine their probability? I mean, like, is all of them equal, or people more likely to be adaptive, for example? So.
Actually, this study, when we are doing this study, it was a more simulation and numerical study. So we are simulating all of the scenarios. The P probability value was in this graph, for example, the probability value was showing the changes when 20% of the people, or 40 or 60 or 80% of people were susceptible at the beginning of the experimentation. So we are making all experiment with the different scenarios. You can imagine, like, first we are saying that much amount of people are susceptible and what's going on. When that much amount of people are susceptible, what's going on. And after that, when we are trying to model the real world structure, we are getting the information by trying to fit the model. It's like when you are trying to do Gaussian fitting, you don't know the exact parameters, mean or standard deviation, but it tries to fit when you apply that methodology, right? This is exactly how it is working. You are getting the pattern with different probability values, and then you are trying to understand what are these parameters by looking the real world scenarios. Could I answer your question?
Also, please, could you please introduce yourself while asking the questions would be better.
Yeah, can I? Okay, Eli, could I answer your question?
It was satisfactory, thank you.
Okay, thank you. Do you want me to continue?
Yes, you may, of course. You are.
Okay, free. Then I wanted to and more application-based and maybe more fun too. In this one, we were looking the difference between bots and humans in moral rhetoric, because identifying the bits and pieces of morality components in social media content, such as tweets revolving around certain narratives in Twitter, can help combat the spread of misinformation. And that was the main idea of my whole PhD study. We are trying to combat the spread of misinformation. And what we wanted to look at that is morality, another factor to identify bots, the malicious accounts in any social media accounts you may encounter with. So there are already some studies, when we look at the literature, there are already some studies focusing on the diversity of moral values for different groups on the same topic. Like, for example, in America, it's very common looking for Republican and Democrats on the election, or a single population on various topics. So what we wanted to look at, because they are all considering morality as an average rate or amount over a period of time, we wanted to look at the evolution of the moral values over time and across different sub-narratives. And while looking all these differences, we also wanted to look at these differences in malicious bot accounts and in human posts. For this purpose, we need to quantify the morality, and to quantify, we are drawing from social psychology literature and using moral foundations theory. This theory says that our morality concept is formed by 5 different dimensions, and each dimension has 2 opposite poles called virtues and vice moral rhetorics. For example, the first dimension is care and harm, and that, as you can understand, it relates your moral concerns relating to the protection of self and others from the harm's way. Or authority and subversion is related to subordination and respect. And the other dimensions are fairness and cheating, loyalty and betrayal, and purity and degradation. According to moral foundations theory, which is a well-established theory, by the way, it says we can cover all of our moral concerns by looking only these 5 criteria. And to quantify moral foundations, again, there are some moral foundations dictionaries that we need to use for the machine learning algorithm. And all of them say that they are the best ones. So to understand which one is the good one, we annotated our tweets in the data set, 400 tweets, and we calculated the accuracy of their dictionaries. So we wanted to use, in the end, Moral Foundations Dictionary version 2, and you can see the corpus size of this dictionary on the table here. And to, as you see now, we know the method, we know the theoretical approach in sociology, we have tweets, but we all have textual data and we have a textual dictionary data set. This dictionary, I mean, for example, if a text includes compassion, kindness, empathizing, humane, mother, these verbs are defined as a dictionary values for the care, moral rhetoric. So if any tweet in our data set includes one of these words, it means that it includes some kind of care moral rhetoric inside it. But to understand how strong this rhetoric is, that we wanted to first quantify all of this textual data. And in machine learning, the most commonly used methods are TF, IDF, and Dr. Vec methodology. And this one, we are converting textual values to vectors, and we are calculating the cosine similarity between these vectors to understand how much amount of specific moral rhetoric each tweet includes. As a data set, we used White Helmets data set. White Helmets belong to a civilian volunteer organization that operates in war-torn areas and provides services such as the evacuation of people from bombed areas, search and rescue, delivering medical supplies, etc. We used a data set including more than 1 million tweets, almost 1 million tweets, and all tweets were related to the disinformation campaigns carried against White Helmets. And it was spanning more than a year. And we first wanted to look at what kind of activities or how much activities have been done by users. So this graph shows some bursty activities in the data set with respect to some specific times. And we can easily say that these bursts, these peak points are called as bursts. These bursts are generally due to the special events, special news we have seen in that specific time. So the first one is due to the Doima chemical attack. There was a chemical attack happened in Doima and White Helmets people were trying to help them. And the second one is Trump's aid freeze to Syria White Helmets. And the third one is the evacuation of White Helmets to Jordan through Israel. And although there are 2 important events about the misinformation campaign conducted by Russia and the airstrike happened in Idlib, which causes death of at least 9 civilians, we didn't see so much bursty movement in that time period. Although we know that what happened and what kind of topic it might include all our data set, we wanted to model to make it more reliable. So we use topic analysis to identify different sub-narratives happening in our data set. For this purpose, we use LDA, which is latent riclet allocation. And in this one, machine learning algorithm does everything if you specify how many topics that might exist, how many distinct topics that might exist in the data set, and which kind of solver do you want to use. And in that one, we specify from 2 to 15. We set number of topic from 2 to 15, and we observed best coherence and perplexity scores around k is equal to 4. These coherence and perplexity are the performance measures they are using, and the best scores are also obtained when we use the variational bias solver. So we identified the topics by applying this machine learning algorithm, and they were not surprising. The first topic was related to more like chemical attack in Doima, and the second one was Trump freeze fund, and the third one is evacuation of these White Helmets people to Jordan. And the fourth one was Russian airstrike, civilian strike, kill, Idlib related. All the fourth topic we couldn't identify on the time series data. Then to understand is applying moral foundation theory to this specific data set making sense or not. We wanted to look at the ratio of moral words to non-moral words in this data set. And we saw that almost 57% of the tweets include more moral than non-moral words. So people are, because this topic is quite sensitive, they were sharing more morality related textual data. So it was a good data set to make the analysis. And only 1.7% of whole tweets do not include any moral rhetoric. After that, because we wanted to look at the differences between bot and human accounts, we identified both accounts, and identifying both accounts is really so hard, although it's just one figure I could put here. It was, you are looking for all the consistency of their sharing, how many people they are following, did they follow all of them at the same time, or their account's age is so low. There are so many criteria to identify this bot detection, and this is another huge area in computer science. But in our data set, the method we applied concluded that 5% of the accounts are classified as bot accounts. So the first question was, is there a significant difference between the moral rhetoric of human-generated tweets and bot-generated tweets? First, let me look at these average moral scores for each vice and virtue dimensions, and for each vice and virtue poles and for each dimensions, we saw that humans tend to share tweets that involve a stronger virtue moral rhetoric comparing the bots. We applied man-Whitney test to show the significance of the results. If you look at here, the first one, for example, a human is sharing significantly higher care-related tweets than bots, but bots are sharing more harm-related tweets than humans. The second research question was, does the moral rhetoric of user-generated content of bots and humans on Twitter change over time? Although these values were normalized values because it was to 95% to 5% both, we saw that the strength of moral rhetoric of tweets show stationary behavior with small deviations according to each topic for human. But when we look at to bot-generated tweets, we show that fluctuations show more chaotic structures. The other question we wanted to answer was, does the moral rhetoric of user-generated content on Twitter change across different sub-narratives? And that was the most significant one, I guess, because we observed that bot-generated tweets show almost completely similar behavior. If you look at here, they are all sharing harm-related tweets and not sensitive to the topics at all. But when we look at human-generated tweets, they are making more sensible and predictable explanations in their tweets. For example, the first topic and the fourth topic includes more harm-related tweet rhetoric. So these tweets were related to attacks and people are harmed. So they are using this specific rhetoric to identify their feelings. And when we look at topic 2, it was freezing fund of Trump to Syrian White Helmets. They are sharing more loyalty-related moral rhetoric. And for the evacuation in the third topic, degradation was the main factor we have seen. So we could conclude that There were previous studies already demonstrated that malicious bot accounts try to spread negative contents, but this negativity was only semantically in machine learning. And we also observed that bot accounts use stronger voice rhetoric than humans. This negativity is not only semantically, but also in moral concerns. And the other conclusion was we demonstrated that the moral scores of human-generated content show more stationary behavior over time, so they are more consistent, but while those in bot-generated contents present more chaotic pattern, which is not predictable very easily. And despite the predictable changes for human-generated tweets across sub-narratives, our results for bot-generated accounts did not show any selectivity. So if we scale up our results and show the robustness of our results conducted in this study, we can argue that moral rhetoric can be an important factor in bot detection in the future. I think that's all. Yeah, this is all I can explain today. And thanks for listening. If you have any question, I will be happy to answer.
Ece, that was very good, actually. Thanks again, and thanks for putting my name. And I should say that I'm pretty much proud of you. That was very interesting.
Yeah, I put on the first.
You maybe should put my name there. You just you may thank your instructors. Well, I have a couple of quite a number of questions, but I'm going to go fast. Maybe there may be other people who have questions. Well, okay, first, some general questions, and I also recommend everyone, you may ask any question about Ece, about general questions about, for instance, I'm going to ask whether your education in chemical engineering and chemistry, did it help? And I think in chemistry also, that quantum thing, maybe it helped. Maybe
yeah, actually, I think in chemical engineering department, we are taking physical chemistry until physical chemistry 2, right? I remember in chemistry, I took physical chemistry 3, which was more related with the quantum. And that was the only thing I got from the chemistry, I could say. But actually at the beginning, I was doing more different research, and these research ideas were a little bit more related to the chemical engineering at the beginning, because there was, although the things that I'm doing right now are very different than chemical engineering, at that time I realized that there are so many common things between chemical engineering and the information theory, because all information theory is coming from some thermodynamics idea and all the entropies and everything. They are all thinking same actually, and I was very happy to see that because I was understanding better. But for the things that I explained, probably now I'm not using so much chemical engineering or chemistry background. I think this is completely new.
Okay, I think we have a question, Omar. Yes.
Hello, hi. Yes, I'm actually like the same question, but for industrial engineering. Like the topics seem like very much philosophical or sociology. Or something like that. I mean, I understand the statistics part, but I don't see, I mean, I'm also interested a little bit in industrial engineering, but I mean, like, I felt it was like pure sociology and philosophically, I don't know. And I mean, there is some statistics, but I don't know. I was confused about that part. I mean,
yeah, you're quite right, and this is really a good question. Actually, I didn't want to give so much mathematical details to not bore you, because I just wanted to show that it's some kind of appealing areas to study. I am doing more computational analysis than this, but I am just trying, because everything is related to human and we are trying to do some kind of computational social science. We are getting some hypotheses from these social science disciplines like sociology, psychology, or philosophy, as you said. But the rest of it is actually more data analysis, which is very common in industrial engineering, or the complexity is also another area they are focusing on. But when you say industrial engineering, you may think more related to optimization or more different areas like supply chain or logistics, these kind of things. They are different than, yeah, you are right, it is not pure industrial engineering, but industrial engineering in America is very interdisciplinary area. And the people that I'm seeing in here, everyone is working on I don't know, robotics, for example, or there's another lab working on, again, complexity or the networks. Everyone is specializing on different things, but they are not pure industrial engineering every time. So you may find that kind of industrial engineering programs too, but as far as I've seen, I think it's like 50-50% probably. They are also working so interdisciplinary. But these things I have explained were more, look like more hypothetical and more social science, but actually there were more analysis. Just I had limited time and I didn't want to give all details.
Something else, the size of the data set, it seemed very small. I mean, you were talking about big data and Twitter data. I mean, there should be like millions or at least thousands of data points that could give you more robust results to use, I mean, in such a study, right?
Actually, it was big. I think it was big for me. I don't know, but it was big because it had more than 1 million tweets, and we collected these tweets when they are, these activities, they were more famous, and this misinformation campaign were conducted in that specific year. So we didn't want to make data sparse, and we didn't want to get unnecessary data, but wanted to focus on this 1 year. Instead of trying to achieve a limit, like how many data set we will have, we wanted to keep time span as distinct, and from April 2018 to April 2019. So we could collect 1 million data in that time period when we specified data.
So you said something about 400. Is that like 400 account, but 1 million tweet, or?
Yeah, no, that one was, we didn't know which dictionary we will use, because there are different dictionaries and all of them are including different words for specific moral dimensions. And all of them are arguing that we are the best one, and they are very recent ones. So we wanted to understand which one makes sense for our data more, because apparently the extended one is the third one, is the most enlarged one, but it didn't work when we annotated tweets. This was just because if you annotate all of tweets, there is nothing to do with machine learning. So we just wanted to annotate some of them by ourselves, and we wanted to check with people our results. And then after annotated this, we selected only the dictionary, but then we applied all the methodology to this 1 million data after that.
So what kind of machine learning were you using?
The machine learning here we were using was mostly textual vectorization to make the similarity between this dictionary and make the analysis or quantify this moral rhetorics. We need to identify all the textual data as a vector. So what we were doing here, the first one was applying this vectorization. The thing I try to explain here, we were using TF, IDF, and Dr. and then calculate cosine similarity to quantify these morality values in each tweet. After this, we were using a topic selection to identify the sub-narratives, and we use latent triplet algorithm here with variational bias solver. Okay. Machine learning was not the aim. Machine learning was just the method we were using to identify some of them, actually. It might be more like a data analysis here and more like an explanatory study. It wasn't so theoretical, something we just used as a tool, I could say.
Okay, thank you for your answer.
And by the way, the original presentation Ece has shown me was too much technical with all those quantum things that I got no idea about. So it's my fault if it's a fault that it's not that much technical, but I thought this would be much more easier for people to grasp. So the original version was pretty much complicated. And as far as I understand, what you call here as dictionary is like base vectors or something like that. So you have the X vector is that tweet. So with respect to that base vector, how can you show it within that space? And you have another set of base vector, what you call dictionary. Okay, so that's.
Yeah, we are just looking vector similarity and how close these vectors to each other in that specific space.
Using different dictionaries may give you different similarities, actually.
Yeah, that is the reason we wanted to annotate first, because some of them are binary. making binary prediction at the end. Just labeling is like 0 or 1. It includes or not including. Or for example, the last one is identifying as a continuous value between 0 and 1. And this was causing so much noisy data, so we wanted to keep it a little bit simple, but still enlarge. And also the annotation gives the best result with the second one, so we wanted to use that one.
Okay. Still, even this much is pretty much complicated, but I think it's very good. Well, I got 2 questions. So if there is anybody who wants to ask a question, you may interrupt me. My first question would be technical. The last one is going to be totally about how you did your PhD. Well, the first example that you shown was very interesting, that people knowing the result of the first game, people knowing the result of the first game, and you ask a question, then people who knows the result, yes, you won the first game,
That's
you
right.
lost the first game, you don't know. Well, actually, this is the first time in the previous slide, yeah, you have written all these things, but I haven't went through details. So this is the first time I thought about this. So while I usually do that, while I'm reading something, I also think about how can I solve this question? And what I would have done would be, for this specific case, would be to divide the space again in classical terms into 3 separate things. The first one, or actually into 2. I have information about the result. I don't have information about the result. Then having information about the result is winning and losing. But as I see, I mean, like I thought about myself, uncertainty is, as far as I can understand, you put uncertainty in top of those 2 known states, right? As a kind of distribution function. So there is uncertainty everywhere, but as you go along the 2 extremes, you become more certain, kind of. Maybe that's Bayesian thinking, and I don't like that Bayesian thinking, and it's even in myself. What I would have thought about is still uncertainty is another state. And I would have
if you define it, yeah, but yeah, most 100% certain and completely uncertain will be 2 different complementary states you can make.
From that perspective, you can understand why this probability thing doesn't work, because uncertainty is not an expected value of being, how can I explain? This formula itself assumes that uncertainty is the superposition of winning and losing. From my perspective,
this is the interference
is totally different, right? But
it depends on the state you are defining, I guess. If you define the state like winning the first game, and if you don't put the uncertainty as a factor while defining the state only, I think still it shows the violation to shooting principle, because the idea was that, but I think it might be predictable with other methods too. I don't know, I didn't think about this at all. But
do you see my point? So state,
I understand what you
say. Is a
say.
3rd state, because when I think of that, people don't like uncertainty. I mean, whether you win it or
we want to show the violation not to be actually these people probably wanted to make 2 different distinct opposite states.
You show violation, or this game shows violation by not assigning uncertainty to another world. So it divides the world into winning and losing, and that's all. But from my perspective, I would have divided the world into 3, but that's just my perspective.
Then we cannot show that shooting principle is violated, because in that, that specific theory, they are identifying 2 complementary states. But it might be more predictable if we do how you are suggesting. Yeah, you're right. But I don't care. I'm just taking the motivational part from this.
I changed the whole thing from the beginning. So actually, it is uncertain world, certain world. I divided in that certain world, we win and lose. But we behave uncertainty and certainty, even certainty of different conditions, differently, I think. From my, I mean, that's what I would done. And I don't know any idea about quantum mechanics. Maybe